This is our last set of notes for the year. Today we're still applying exponential functions. You can use the date on your notes of June 11th. And we're going to finish up this note packet. So we're going to pick up at the bottom of page 3 here, and you'll need these 2 pages as well. The last topic that we're going to talk about is called compound interest. So basically what's going to happen is you make an investment or you put money into the bank. You're going to be awarded interest at some point during its deposit, and then your balance is now bigger, and we're going to keep adding to the total, but they're going to keep adding interest, so it accumulates over time. This little graphic kind of shows you what's happening. If you invest $1,000 and they're going to give you 10% interest, that first interest period will earn you another $100, but now your balance is the 1,000 plus the 100, so now it's 1,100. But now they're going to give you 10% interest again, so they're giving you another $110, so now your new balance is 1,210. And this pattern continues until you take money out or close your account. This is the compound interest formula. It is very much an exponential growth function. What you'll see here is A represents the amount of money in the account or the interest. P is the principal. This is really A, our initial amount. So that's how much money we're investing. Because it's a growth rate, it will be 1 for 100% of your investment plus, instead of this just being a set growth rate, we're going to use the growth rate R in the form of a decimal, but we're going to divide it by the number of times per year we're earning interest. So we'll talk about those different variations in a second. And then the exponent has to change as well. So it's time in years, but also being multiplied by the number of compoundings that will happen each year. So it really is a growth model, A times B to the X power. It's just been modified slightly to include the different areas of interest. Some terms that will help: if they're only awarding interest yearly, they will say yearly, but it's once per year. So the number of compounding cycles is 1. Semi-annually, that means it's twice per year. So you'll receive your interest twice, probably June and then probably December. Quarterly, quarters, 4 quarters, 4 times per year. And then monthly, 12 times per year. There are other ways. When you have a credit card, they actually compound the interest daily. So they look at your balance and they charge you interest for using their money every single day. In our first example, it says determine the amount of an investment of $500. If it's invested at a rate of 5.75% compounded monthly for 25 years. So the amount of interest, or the amount in the account, we're going to start with our formula. Our initial amount, or A, our principal is 500. The rate is 5.75, but I need to move the decimal 2 places to the left, 0.0575, and it tells us it's compounded monthly. It's 12 times per year. So this is my denominator, and then the exponent is 12 times a year for 25 years. You can go ahead and calculate the value of this fraction. And when we put it together, we also have an exponent of 300. And now I recommend just putting this right into your iPad. That initial investment of $500 will be over $2,000, actually almost $2,100 after 25 years. Make sure you round this to dollars and cents. In example 6, we're going to determine our investment of $100,000. We're going to earn 5.2% interest quarterly, 4 times a year for 12 years. So the more you invest, the more you should end up with. So A, our initial amount, or P, the principal, is 100,000. The rate as a decimal is 0.052, and we're going to receive interest 4 times a year. We're also going to show that outside as the exponent, 12 years, 4 times per year. So again, I'm going to simplify the exponent and the fractional rate. and my money should grow. So after 12 years, I should have over $185,000. That's all there is to it for compound interest. This will be homework number 130. This worksheet is what you're going to do. There's only 10 problems, so you're going to complete all the problems. Make sure you show me formulas and all the work that goes with it. And this is our last assignment for the year. Have a great day.